Yes, so as RT says, I've been working to develop a new feature for DRBD with the goal of reducing resync times. So as he said, the feature is called Resync without replication, and can either reduce the resync time or reduce the amount of bandwidth used during resync. They sort of go hand in hand. Let me set up my screen share. Okay. Hopefully you can now see what's going on here. So I'm just going to start a resync here and without the feature, and see what I'll show you what it's demonstrating.
I'm sorry, I think it might be better to create a larger text.
Okay.
It will not be seen on YouTube.
Yeah, the main things to see are on the left in the diagrams. Anyway, but I will see if I can go a bit bigger. And this one I can go bigger. Thank you for the feedback. Okay, so what do we see here? We see a diagram of application bandwidth and resync bandwidth here. So we started an application that's writing at a constant rate up here. And there's a resync here. The network is limited to 20 megabytes per second, and so resync just uses what the application leaves free. And we see here the bitmap of DRBD. So what we've simulated here with this test was a disconnection, and while it was disconnected, we wrote some things, so didn't want to keep you waiting, so in the background the test just writes a couple of minutes worth of data, fills up the disk, and then we reconnect again and the resync starts. And what we see is that the resync goes on like this. Let me zoom in a bit. So bright colors are bits that are out of sync, so set bits in the bitmap, and dark is when it's in sync. And so we see that DRBD's resync progresses from the beginning of the disk through to the top, and at the same time the application's continuing to write, so some blocks are brought in sync by application write. So that's why these are getting darker from left to right. So the application hits some blocks and they get in sync too. So that's the way that DRBD's resync works currently. So now let's try switching on the new feature, resync without replication. Okay. Let's see, it's going again, but there are some differences. So we see that the blocks are no longer being resynced by application I/O, because with this feature, we don't no longer send the application I/O while the resync is happening. And so only when the resync gets there. Also, we see that after the resync has been to a block, it may get written again and become out of sync again. And so DRBD does a couple of passes through, and at the end it does then re-enable application I/O for the end so that the resync can actually complete. So, but what do we see here? Here we see actually the new feature, the resync, took longer, which is not what I advertised. I claimed this feature had the purpose of decreasing the resync time. So why, what is its point if it makes the resync take longer? The point is that this is not actually the typical case. In this test, which I've started with, we're doing random uniform I/O across the whole disk, and that's not the normal case. Normally, you'll have certain areas which are hotter, which are continually overwritten, and other areas which are less less hot. So let's try replicate. Let's try a test of that. So again, this is with the feature off and with a non-uniform distribution. It's called ZipF. Not something you're likely to be familiar with. It's just a distribution which isn't uniform. Some areas, some blocks will be chosen more often than others. And we're also going to add an area that's supposed to represent a database log, so write log, which is especially busy. And then we start that off without the new feature. We enable new. So in the middle here, we see this database log simulated. And across the rest of the disk, we see it's unevenly out of sync. And the resync is progressing through as before. And that's finished. Now we try and do the same thing with the new feature. So this turns off replication during the resync at the start at least. And see what results we get. And the resync's done already, no more resync traffic here. Zoom in on that. So here we see with a more typical use case that the resync time did reduce. They took from here to resync, whereas previously it took from here to here. So the reason it's become less is that we've now got this case where certain parts of the disk are being rewritten often, they're being overwritten. And when during the resync, we don't need to send all those writes every time. We only need to send the last one. Of course, we don't necessarily know which is the last one, but we only need to send the data once, really. And so we save on bandwidth and time by not sending all of those repeatedly written blocks. The disk on the target side is inconsistent anyway, so it can't be used. So it doesn't matter that it's not getting the most recent application I/O. So this is kind of the key view. This is a fairly modest improvement. I tried to create a somewhat representative test showing something that could be realistic. We can also get more extreme results if we, for instance, have a full sync, a DRBD full resync for the whole disk, and a small amount being written very often. So yeah, well, let's try that for fun. So without the new feature, let's get rid of that and just concentrate it with the higher values. That will concentrate it on more and turn on the full resync. So now we've told it to do a full resync, so it's made all the blocks out of sync. And so that's why everything's white to start with. And because only some of the blocks are being rewritten most of the time, we only see a little bit being made in sync by the application I/O, and so it takes a while to do this. So a bit of a slow process to resync the whole disk while there's still application I/O going. And that application I/O isn't helping either. So off it goes. Yeah. Nearly done. Now let's terminate this. Getting a bit boring. and enable the new feature to see what happens in this extreme case with the new feature. So we see the resync is now able to progress much faster because it's not competing with the application I/O for bandwidth. Resync rate is right up at the available network bandwidth rather than being stuck down here. And so it progresses right through and it's already finished. Let's zoom in on that. So here we see it being significantly faster. This should have been even longer. I cut off the application just to speed it up a bit. And that shows the resync progressing through. And then at the end, clearing up the last few blocks that were written while that first pass was happening. So I hope you enjoy this feature and can try it out once it's released. We're planning to release a DRBD 9.3 series soon, and this will be the first in the first release of the DRBD 9.3 series. And once it's out, then I'm looking forward to your feedback on how it performs on with real-world applications. The performance difference is very dependent on the exact parameters of what the application is doing, what's being written, how much is out of sync, what the relative speed is of the application and the network capabilities and network bandwidth and so on. So that's all from me. I'm ready for questions. Anyone got a question? I want to see anything again?
I don't have a question. I'm just commenting. It's a great way of showing this. So amazing.
Give it a second here while we wait for any questions to come in. Awesome presentation, Joel. Super excited for this feature to come out. You have one that looks like it came in from Bjorn in the YouTube chat here. The ask is, will this feature be turned on by default?
That's a good question. Something we need to decide. It certainly won't be turned on by default for older versions. We probably won't turn it on because there are cases which it makes worse. And so for the sake of backwards compatibility and not breaking existing setups, we'll probably leave it. But we may decide that a change of DRBD version series is a sufficient justification for making such a change. So that's still open. Good question.
Awesome. Thank you, Joel. And also just a quick plug, if anybody out there is wondering if this feature could work for you, we are happy to help you get it tested in a lab environment. So just putting that quick little nugget out there in case anybody's interested once it does get released. All right, give it a second here. We are going to call it going once, going twice. Get them in while you can. All right. Thank you, Joel. If anybody does have any questions, as I mentioned before, please put them in the YouTube comments. We'll be happy to get them answered for you.